Hello everyone, welcome to Pepcoding. So in this video, we are again going to start with a new question. Okay, so the question that we have this time is construct BST from in-order traversal. Okay, so in this question, an in-order traversal of a BST will be given to us in an array. Okay, basically an array will be given in which the in-order traversal elements will be there in an array. Okay, so what we have to do is we have to construct the BST from that array. Okay, so we know that in order traversal of an BST, the in order traversal of a BST is sorted, right? It's sorted. Why is it sorted? Because in a BST, the if the root element is suppose 25, then the left will be smaller. All the element in the left will be smaller. All the element in the right will be larger. Okay, so this is what happens in our BST. Okay, so this is why our in order is sorted for our BST. Okay, so we know that a sorted array will be given. Okay, now we know that a sorted array will be given. We just have to make a BST with the help of this array. Okay, so how we can do this? So for this, what we can do is we can find a element which we can make the root. Okay, we are going to find an element to which we can make a root, and from that root we will make its left, make its right. And when we will do the work for this, after that we will say to our recursion that I have did the work for this one, please do the work for others. Okay, so it is completely my faith and expectation thing. So what is my faith? See, so first of all, let us talk about the expectation. So my expectation is I'll do some work, and after that, after see, my expectation is that I'll get the BST. I'll get binary search tree from this array. Okay, from this array I'll get binary search tree, and my faith is that I will make a root. First of all, I will make a root, and I will make the left of it, and I will make a call for right of it. And with this, my recursion will settle all the left side, and my recursion will settle the right side. Okay, all the element in the left side and all the element in the right side, my recursion will settle them and will make the BST of them. Okay, but I will make this root a BST. Okay, I will make this root a BST, and from that faith only my recursion can make other nodes also BST nodes. Okay, so yeah, so let us start with the approach. So what we can do in this is, see, we have this sorted array. So what we can do is we can find an element. We can find an element that is suppose 45. Okay, so if I make 45 the root, so what I should do, I should make the left and the right of it such that all the elements in the left, I'll place some element in its left, so that the left side will be always smaller than that of root, and the right side will always be greater than that of root. So the tree that we are going to make here will be the balance by binary search tree. Okay, balance BST. So what is balance BST? In balance BST, the searching time is log n. Okay, it will take the logarithmic searching time, and yeah, so let us see how we can do that. So how we can do that is, see, we will take a mid node from this array. Okay, so the first index is 0, the last index is 9, right? That is, the size is 10, so last index is 9. So now I'll find the mid. So mid will be starting index plus ending index by 2, right? Starting index plus ending index by 2, that means this one, fourth. This is fourth. So 25 will be considered as my root. Okay, now I'll make 25 as a root. So I'll make 25 as a root, and we'll say that to its left I'll send some elements from SI to mid minus 1, because my mid is already been solved. Okay, my mid is root now. So from SI to mid minus 1, that is still here. So from this to this, it is my left side, and from this to the end, it is my right side. That means mid plus 1 to ending index will be my right side. Okay, so this is what I will do, and how I will do it, let us see. So in this case, in this case I will have okay, just allow me a minute. It is fine now. So what I will pass this side, I will pass 0 to 3, right? That 0 to 3 will make their BST to the left, and 5 to 9 will make BST in the right. Okay, so the mid is 4 here, and it is from 0 to 9. Okay, this is what I'm writing. So what will be the root here? So here the root node will be, for them the root node will be 2 0 plus 3 by 2, that means 1. So 1 will be the root node for them. So let's do this. So 1 will be the root node, and it was from 0 to 3. Okay, 1 was the root node, that means 9 will come here, right? 1 is index, so element is 9. So 9 is the first element, that means index element at index 1. So here the left and right will be passed. So now what will be the left? The left will be si to mid minus 1, that means 0 to 0, and the right will be mid plus 1, that means 2 to ending index, that is 3. Okay, and for this, okay, let us resolve the left side first. Okay, and then after that we'll go to right side. So what I will do is, from 0 to 0, from 0 to 0 the mid will be 0 only, mid is 0 only, that means 5 will make itself as a root. Okay, and in the left it will send si to mid minus 1, that means 0 to 0 minus 1, 0 to minus 1. Is it any range, any element in 0 to minus 1? Can you see any element from range 0 index to minus 1 index? I cannot see any element in this range. Even I cannot see index minus 1. Okay, so we have to return from here, and what we will return? See, no element can be the right, or can be the left child of this 5. Okay, no element can be the left child of this 5, because no element in the array is smaller than 5. Okay, so from here I'll return null pointer. Okay, I'll return null from here. So the left child of this 5 will be null. Okay, and in the right, what I'll send is, I'll send mid plus 1 to, I'm writing here, I'll send mid plus 1 to ending index in my right, and here si to mid minus 1 in the left. Okay, so this is what I'll do. So now in this 0 0 was there, right? So mid plus 1, that means 1 to ending index is 0, so 1 to 0, it is again out of range, right? There is no range from 1 to 0. From 1 to 0 cannot be any element, so it will again return minus 1 now. Okay, so minus 1 will be returned, I mean minus 1, not minus 1, null pointer will be returned. Okay, so null will be the right child of this 5. Okay, so I hope this is clear. So now for this the right child, for this the right child. So what will be the right child for this? 2 to 3 the range, 2 to 3 is the range, that means 2 to 3 means 0 1 2 to 3, that means this element. So the mid of 2 to 3 is 2 plus 3 by 2, that means 5 by 2 means 2, that means there's 16. Okay, so 16 will make itself a node, 2 to 3, and 2 is mid, right? 16 has made itself a root node, and then the left will be si to mid minus 1, that means 2 to 1. There is no element in this range, because si here is greater than ei. Okay, no element in this range. Now this right side will be mid plus 1, 3 to 3. Okay, mid plus 1 to ending index, 3 to 3 has an element 18. So here we will attach 18, and its left side will be 3 to 3 will be there, right? 3 to 3, so left side will be si to mid minus 1, mid is 3, so 3 to 2, there is no element, so null. Now here it will be mid plus 1, that means 4 to 3, so there is no element in this range, 4 to 3, so it will again return null, and the child of 18, left and right child of 18 will be null. Okay, and here it is 2 to 1, it is also null. Okay, so now we move back. My left tree is being completed now. See, 25, then 9 is smaller than that, then 5 is smaller than 9, 16 is greater than 9, and 18 is greater than 9, and 18 is also greater than 25. Okay, so all the elements in the left are arranged in a BST order. Okay, so we can say that this tree right now is a BST. Okay, till now is a BST. So now we'll, okay, let us make it little here. Okay, this side. So what was it? It was 0 it was 5 to 9, right? 5 to 9 was the range. So yeah, let us make it. So how we can make it? So for this, what I'll do, 5 to 9. So first of all, mid 5 plus 9 by 2, that means 5 plus 9, that is 14 by 2, 7 will come here. So 52 will be the root node, and the left and right. Okay, so left is 7 is mid, and 5 to 9 was there. So SI, that means 5 to mid minus 1. Mid minus 1 is 6. 5 to 6 will be here, and mid plus 1, that is 8 to 9 will be here. Okay, so 5 to 6. In 5 to 6, what I have is, see, this is my 5, this is my 6, right? So in 5 to 6, I have two elements, 30 and 45. So mid of them is 5, 6, mid is 5. That means 30 will place here. Okay, and as the mid is 5, 5 to 6 is range. So what I'll do, I'll put the left and right. So my left will be SI to mid minus 1. That means mid is 5. So that will be equal to 5 to 4. There is no range from 5 to 4. SI is here greater than EI. So this is the case where I should return null. Okay, I should return null. The left child of this 30 will be null, and the right child will be mid plus 1. That means 6 to 6. 6 to 6 has one element, that is 45. So 45 will be the right child, and now null will be the child for 45. Okay, in the same manner. So now 8 9 is remaining, right? So for 8 9, what I will do is, see, 8 plus 9 by 2, the mid is 8 plus 9 by 2, that means 16 by 2, 16 17 by 2, that means 8, that means 67 will be placed here. Okay, 67 will be placed here, and the left will be 8 9. Okay, and the left side will be SI2, that means 8 to 7. 8 to 7 does not contain will not contain any element, as 8 to 7 cannot be any range. Here SI is greater than EI. We should return null pointer from this point. Okay, so the null will be returned from here, and for this side we will have a mid plus 1, that is 9 to 9. 9 to 9 contains one element, that is 72. Okay, mid is 9. 9 will make itself element at 9 will make itself a root, that is 72 will be created as the root, and here the null will be the child for this. So this is how my complete BST will be created. So I created one root by finding the mid. Okay, I told my recursion that my left will be the element to starting index to this mid minus 1. Okay, and I told my recursion that my right elements will be, the right of this root will be my mid plus 1 to ending index. Okay, so this is how my faith meet with my expectation. Okay, so after this we'll begin the code. Okay, so let us go to the code and try to code it in the same way that we have completed here. Okay, so let us code it. Okay, so first of all we are going to code this in Java. So let us begin. So what we have to do, we have given this function. Okay, but we need 3 elements in it, right? We need in order also, an array that contains in order, and we need some indexes so that we can pass those indexes, and from that our function can choose its root and choose its left elements and right elements, right? So but here we only have this array, so we should make a function. Okay, because I'm not doing it right here because I don't want to change the function declaration, as the call will directly be made to this only. Okay, from this, if I'll change it from here, I need to change it into the main also, so I'll not do that. I'll just make my new function public static node, and it will be construct BST. Okay, and what I'll pass here, I'll pass this array and I'll pass starting index, I'll pass ending index. Okay, so what I'll do, first of all, mid, right? So int mid is equals to what it was si, it was plus ei by, okay, so it was my mid. Now my tree node of what, uh tree node of root, right? No, tree node root, yeah, root, we are making root, is equals to new tree node, what, new tree node, and we will pass what in this, will pass array at mid, because array at mid will be created as the root, right? So this is my root, and then my root dot left. What will be my left will be made by my recursion. Okay, left will be made by my recursion. I'll say arr, and the range will be from si to mid -1. Okay, the left range will be si to mid -1. And what will be the right range? So root dot right will be construct BST, and it will be array and mid plus 1 to ending index. Okay, and then what I should return, I should return my root, right? But as I'm running a function which is running on recursion, so this recursion should stop at some place. What will be that place? That will be when where am I here? So when my si will become greater than ei, okay, then when starting index will become greater than ending index, then at that point I should return null, right? The null will be the right or left child for that. Okay, yeah. So now what we need to do, we need to call this function from here. Okay, because in main it will be called, so construct BST, it is BST, and we pass array, what array it is, the name is InOrder. We'll pass InOrder, we'll pass 0, and we'll pass in order dot length the ngdh -1. Okay, we'll pass this. So this will be the starting index 0, and ending index will be in order dot length -1. So we'll pass the starting and ending index first of all. Okay, and then our recursion will do its work. Let us give it a run and check if it is running or not. Giving us some compiling error. What is this error? Okay, return spelling is wrong. Where is it? Return. Okay, cannot find symbol. Return construct BST. Okay, return method construct BST. Okay, it is okay. What I have written, construct. Okay, not CONS, right? CONS, construct BST. So construct BST. Okay, construct BST. So let us give it a run again. Okay, so accepted this time. Let us give it a final submit for all the test cases. So it is accepted for all the test cases. So I hope you got this question. Okay, and the searching in this binary tree will be log n. Okay, the searching time complexity will be log n. As we can see, the element in the right are greater and in the left are smaller, so we can go to the left or right as per the number that we have to find. Okay, so that's all for this video, and now we will meet in the next video. Till then, goodbye. I hope you got this question. So don't forget to like this video and subscribe the channel. Till then, goodbye, take care.